Flip a coin 100 times, and on each flip, record whether you get heads or tails. At the end of the 100 tosses, go through and count how many heads you got. In this example, I got 53 heads, so the proportion of heads was 0.53. Now, toss the coin another 100 times and do the same thing. Once again, record the proportion of tosses that came up heads. Suppose we do this 10 times and end up with this list of results. We can visualize them using a bar chart. For example, the bar above 0.53 will have a height of 3 because this final proportion of heads occurred in 3 of our experiments. And so on. The bar height is simply how many times that proportion was observed. Now, what if we repeated the coin flip experiment 15,000 times, recorded the proportion of heads for each one, and made a similar bar chart? A surprisingly well-defined bell shape emerges. The shape of this curve is not arbitrary. It's actually a scaled version of this function. Notice that both pi and e show up in the formula. The amazing thing is that this bell curve shows up in many different places. Here's a similar bar chart showing the weights of 10,000 adult males. Here's one for the heights of 10,000 adult females. And here's 10 years of daily stock return history. It turns out that many random processes in our world happen to be governed by the same function that describes a series of random coin tosses. If you'd like to discover a different side of mathematics, you should check out our Math Letters book. We talk about the bell curve in letter 16.